All right, students, Ms. Slyman here with your notes on radians. So we're going to start first with the idea of what is a radian. Well, radians are just another unit for measuring angles. So like we have kilometers and miles, inches and centimeters, kilograms and pounds, we also have two different measures for angles, and we call those radians or degrees. Now, degrees are pretty subjective or arbitrary. Someone some time ago decided that in a full circle there were 360 degrees. All right, but a radian has an actual definition, and that definition is the angle that when we draw the angle, the arc that's created has the same length as the radius. So if I estimate this radius, that's about that long. So I'm going to say it's about, I don't know, that long. So this would be 1 radian. And we use this little C sign to stand for radians. So if this length is R for my radius, then this length is also R. So it looks to me like 1 radian is about 60 degrees. So let's keep exploring that some more. Or stop to really think about this, that the measure of 1 radian, that angle measure of 1 radian is 1 radius length worth of arc. So here we're measuring the arc length like in centimeters. I could also say that this arc has a length of 1 radian if I was going to measure it like the angle. All right, so coming down here, the measures of these angles in radians. Well, this arc length is 1 radius. That must mean that theta is 1 radian. And then my arc length, I could say is 1 radius. Or I could measure my arc length in terms of the angle, so it's also 1 radian. This one now, I see an arc length of 2 radii. That must mean my angle is 2 radians. So the arc length I could either say is 2r in terms of centimeters, or whatever unit we're measuring with, or it's the same as 2 radians. Here I've got an arc length of 3 radii, so my theta must be 3 radians. The arc length, either 3 radii or 3 radians. And notice that this is less than 180 degrees. So my estimate of 60 was a little bit of an overestimate. So 1 radian is less than 60 degrees, but it's pretty close because that's pretty close to a straight line. Well, let's think about how much it is exactly. If we had an angle that rotated 360 degrees, so here our angle had rotated just under 180, but if I had a circle and I have an angle that starts, like my R started there, and then rotated a full 360, so then I would end up back here. Well, the length of this arc is the full circle. So the arc length is the full circle. The arc length, the full circle, is of course the circumference. And of course circumference is 2 pi r. Well, matching up here, 2r turned into 2 radians, 3r, 3 radians. So that must mean my theta is 2 pi radians. All right, so here's my radians. 2 pi radians is the same as 360 degrees. Divide both sides by 2. Pi radians is 180 degrees. Continuing to divide, if I went with pi over 2, divide both sides by 2, pi over 2 radians is 90 degrees. If I had divided both sides by 3, pi over 3 radians is 60 degrees. If I had divided both sides by 4, pi over 4 radians is 45 degrees. Divide both sides by 6. Pi over 6 radians is 30 degrees. And of course, these are our special angles, so it's really handy if you have these memorized as well. But if you forget, pi radians is 180, and of course you can always do the division to help you.